So let's get started. Today we are going to talk about the mass movement on slopes. Also, it's known by mass wasting. So if you find the term mass movement or mass wasting, they mean the same thing. And mass movement, it's very crucial in civil engineering because, like you can see in the picture here, if you are going to have a mass of soil which collapse like this in a street, it's going to block the movement, and also is going to destroy the road here. And we have many ways in order to prevent something like that in civil engineering. Later on, when you move on your courses, you are going to learn many techniques to prevent such events. And we know that the Earth is not a flat, right? I mean the landscape itself. It's not flat. We have ups and downs. I'm going to have ups and downs. I'm going to have slopes like this one, because the land of the earth is not flat. So I'm going to have ups and downs, and I'm going to have slopes. And we know that the slopes are the most common elements in our physical landscape. We always see slopes. And we can say that the slope looks stable under the influence of gravity. But that may change for one reason or another. And if the stability of the slope is going to change for any reason, like you can see here, catastrophe will take place. Because if that mass of the soil is going to deliver in that populated place, we can see many casualties. We can say that sometimes if we can notice a movement in the slope, sometimes the movement is gradual and it's difficult to see any changes. In that case, we are safe. But sometimes the slope is itself, the movement of that slope, the movement of the soil here or the rock is going to be disastrous. So at one extreme movement may be gradual and practically imperceptible, which means that it's difficult to see any changes. In that case, we are safe. And some at the other end, it may consist of roaring debris flowing or flow, or thundering rock avalanche. We know avalanche when you are going to have a slab of snow sitting upon another weak slab of snow, and if there is any slide between the upper layer and the lower layer, then we are going to witness the avalanche. So the mass movement, it could be nothing or it could be catastrophe. Also, we have the term landslide. Landslide is the basic geological process of mass movement. So landslide is a type of mass movement. In the landslide, we are going to see a sudden event. The event itself is going to take place quickly, and we are going to see large quantities of rock and soil move down steep slopes. So landslide is a type of mass movement, and it's known by its quick event, and we are going to see large quantities of rock and soil. The mass movement, we say that also it's called mass wasting, refer to the downslope movement of rock So are going to see down slope movement. It could be from rock, or it could be from regolith. Regolith mean we are going to have loose and weathered rock, or it could be from soil. And of course, all of this is going to be under the control of the gravity. And the mass movement, it has crucial role in the landform development. Many land is going to deform due to the mass movement. And actually, the mass movement is going to be followed, or before the mass movement, we are going to see the weathering. So the mass movement often follows weathering. After the weathering is going to happen, then after that, we are going to witness mass movement. And if I have mass movement along with running water, then the effect is going to produce stream valleys. So if I have mass movement and also I have running water at the same time, as a result, I'm going to expect that to see stream valleys. In order to understand this, we can look at the Grand Canyon. The Grand Canyon is located in Arizona. And like you can see here, the channel of the Colorado River, this is a channel of Colorado River here. And the walls of the canyon extend far from the channel. So the wall of the canyon is far from the channel. We could expect that the walls of the canyon, it should be here, not here. But because of the weathering and then followed by the mass movement, as a result, we are going to see the walls is going to be like that. And if I have running water along with the mass movement, we are going to see the river here. Like we just mentioned here, if I have mass movement and running water, that will produce stream valley like this one. And the mass movement, the effect of the mass movement with the time, also it has a strong effect. Actually, the most rapid and spectacular mass movement events occur in the area of rugged and its geologically young mountains. Areas of rugged mean that it's area that is not even. It's difficult to travel over it. So if you have area like this one, the mass movement is going to take place in that area. Okay. And through the time, the mass movement and the erosional processes slowly is going to change this wrecked mountain to be subdued terrain, which means that first I have area which is not even. It's not easy to travel over it, but because of the mass movement and the erosional processes, then that mountains is going, or that areas is going to be soft areas, soft terrain. Of course, that it will require a lot of time. And again, we need to remember gravity. Gravity is going to control everything. Gravity is going to control the mass movement. But we have factors which going to trigger or start the mass movement. The mass movement mainly is going to be controlled by gravity. But I have factors will help to start or trigger the mass movement. The first one is the role of the water. If you can see here, if you have a dry sand, if you can take a small sample here, and we are going to magnify it, and we can see that we have pores between the sands grains. Here, the sand stick together because of the friction. Because of the friction, we have cohesion. And if you put small water inside that porous here, the cohesion is going to be improved. You could build castle with small amount of water. But if the porous is fully saturated with water, like this case, we are going to lose the cohesion completely. You cannot build anything with that. And that is the role of the water. So if you have a water which is completely filled the porous, we are going to lose the cohesion, and as a result, we are going to trigger the mass movement. So if you have a stable, if you are going to have stable slope, and then the porous of the soil in that place is going to be saturated, then we are going to lose the cohesion, and as a result, we are going to trigger mass movement. And that is the role of the water. Any questions so far? Any questions so far? Okay, let's move on. Like you can see here, we have stable slope, and because of the saturation of the water, we trigger mass movement. And also we have something called overstepping slope. And this one is the phenomena where the material is going to be stable at a certain angle. And if you have unconstellated granule particles like this one, which means that the soil is not compacted, we are going to assume stable slope at a certain angle. And that angle is the angle of repose. So at the angle of repose, the material is going, the slope of the material is going to be stable. And it's different from one material to another. For example, if you are going to have well-rounded sand, this one is going to have a small angle. But if you are going to have irregularly shaped gravel, it's going to have a larger angle. So this one is stable at larger angle of repose, and this one is stable at small angle of repose. If I'm going to increase that angle here, this material will not be stable. Of course, if you decrease the angle, the material is going to be stable. And the steepest angle at which a material can remain stable is the angle of repose. So if the material is stable at the angle of repose, why we are afraid from the overstepping slope? Because this is a critical angle, which means that if anything happened here, is going to destroy the stability. So overstepping slopes are unstable and can trigger mass movement. For example, look at that figure here. We have the slope, which is overstepping hill slope. And here we have a house And unfortunately, heavy rain took place. And we know that the role of the water here, and if the saturation percentage is going to increase, which means that a part of the cohesion is going to be lost. And if that angle here is overstepped, then a mass movement will take place. Like you can see in the other figure here, as a result, we are going to see mass movement. But if that angle was not overstepped, we have a chance of not to get mass movement. So overstepping slopes are unstable and can trigger mass movement. Also, we have the role of vegetation. Since we were children, we've been told in school, the trees is very important. And the reason for that, we've been told that the plants or the trees is going to protect us against erosion. That is why we've been encouraged in order to grow trees as much as we can. And the plants or the trees is going to bind the soil and the rock or regolith. They are going to bind them together. Like you can see here, through the roots, we are going to enhance the stability of the slope. So if I'm going to have a slope here, without that trees, the slope, it could fail. So if you are going to remove the vegetation, we are going to trigger mass movement. So if I have a situation like that, if I have dangerous slope here, if I'm going to remove the vegetation from that place, then that place is going to be susceptible to mass movement. The vegetation also is going to be removed by forest fire. Now we are going to hear a lot of forest fire. For example, in Australia, we have a lot forest fire, also in California. And also, it could be removed by humans. Humans remove trees or plants in order to get timber, in order for farming or for development. The last trigger is the earthquake. If you are going to have earthquake or aftershocks, that can dislodge rocks and unconsolidated materials. So if I'm going to have a slope which is stable, but unfortunately earthquake happen at that place, then that will trigger the movement of the rock and the material. And as a result, I'm going to witness mass movement. Example for that, in 1994, in Northridge earthquake in California, trigger about 11,000 landslides. It's real catastrophe. Also in 2008, earthquake in China caused landslide, which created temporary dams, which means that the landslide blocked the river channel. An earthquake created lakes. So we get witness a lot of catastrophe because of the earthquake. The earthquake is trigger for mass movement. Another question here, could we witness a landslide without any triggers? Is that possible? We said that we could have, or we could start a mass movement because of the earthquake, or because of the overstepping slopes, or because of the water. If the water is going to saturate the soil, and also if we are going to remove the trees and plants. But if I don't have any of these triggers, will I be able to see mass movement? The answer is yes. Because with the time, the strength of the soil itself is going to be weakened over the time. And if that's the case, the stability is going to be lost and landslide or mass movement is going to happen. And this one is very tricky because you'll not be able to know at which time we are going to lose that strength. And accurate prediction is impossible. So if you are going to see mass movement without any of the discussed triggers, the situation is going to be dangerous because it's difficult to predict the mass movement in that case. Any questions so far? Any questions so far? Okay, the last point here.
Doctor?
Yes, please.
I need to ask about you on slide 9 about the degree of Helios. It's the same as the test of cement in the field?
Which one?
Here about this,
about
yes.
the slump test?
Yes, the same idea?
No, it's different. It's a different idea. It's completely different. We are going to, when you are going to take the civil engineering materials, I'm going to explain the difference between the slump test and this one. The slump test actually depends on the amount of the water. If you are going to have a lot of amount of water inside your concrete, in that case, you are going to see a large slump or a large deflection. But here, the material itself is going, any material, it has the ability to be stable at a certain angle. If you increase that angle, this stability is going to be lost. Okay, the slump test depends on the idea of the water content. But here it depends on the nature of the material itself. Any material, it could be stable up to a certain slope. And that angle is different from one material to another.
Okay, Doctor,
Okay.
it's clear, thank you.
You're welcome. Any other questions so far? Okay, anyone has an idea how we are going to prevent the mass movement? How the civil engineers is going to prevent the mass movement?
Well, we used some techniques, Doctor, in the past. We used either concrete piling or sheet piling to fix the ground. These are those valid techniques or just core civil engineering?
Yes, we can use something like that, but which the most obvious one? The things that we are going to see in our daily basis, something we already see in our roads in order to prevent us from mass movement.
Planting trees.
Planting trees, yes. But now, do you see any trees when you are going to head from your house to the university, for example? Or if you are going to go to shopping mall?
It depends on the surface of the ground if it's susceptible to planting trees, but I don't know.
Technically, it's difficult to depend on planting trees in order to prevent the mass movement.
Doctor,
for example,
cementing a wall on the soil?
Yes, we are going to build concrete walls. They has a name. For example, the circular road here, the King Abdullah Road. We can see a lot of stables. We have a lot of slopes. You can see underpass. Still, we can see slopes, but that slope are stable. We are going to use something called retaining walls. Okay, we are going to use retaining walls. For example, when you are going to construct a house, first you need, let's say the building is about 10 floors. First, I need to dig a big hole inside the earth. As a result, I'm going to have slopes, right, all around the hole itself. So I need to protect the workers inside that hole from the mass movement of the slides, right? Because the slides is not going to be stable. So in that case, I'm going to use techniques, many techniques. One of the most famous one is the retaining wall. I'm going to build concrete wall to prevent the movement of the soil. Okay, also in the roads, you could see a lot of retaining walls in order to prevent the movement of the soil inside the road or inside the hole, if in case that you are constructing a house. Okay, so it's very important to deal with the mass movement, otherwise you are going to see catastrophe. Okay, any other questions regarding this?
Thank you. Obvious, Doctor.
Okay, and we have many types of mass movement, and we are going to classify this. It depends on three characteristics. Okay, the first one is the nature of the moving material. For example, is the movement because of the rock, the mass movement, the content of the mass movement, is it from a rock or is it from a soil of regolith or unconsolidated material? Also, the velocity of the movement. It could be from a few centimeters per year to many kilometers per year. And also, it depends on the nature of the movement. It could be sliding, normally sliding, the bulk of the material moves more or less as a unit, or it could be flowing. The materials moves as if it were a fluid. So it depends on these three characteristics. We are going to classify the mass movement. We are going to stop here. And if we had a time, we could continue to give you more information about the mass movement. But I think this information is enough for us, because in the next courses, we are going to study the soil, and then we are going to study the foundation design. And in these courses, you are going to get a lot of information regarding the soil, regarding the properties of the soil, and regarding how to design structure against the soil. Okay, we are going to finish the course at that point. I hope you enjoy the course. I hope you get benefit from it. Okay, and I hope you bright future for all of you. Do you have any questions here?